Hey guys, in this video I'm going to run you through an introduction to the notation of functions. So this was new to GCSE in 2017. The notation makes it look probably a little bit trickier than it is. You've actually been dealing with functions for quite a while now if you're in year 10 or 11. Whenever you've said something like y equals 3x, you are saying that y as a function of x is equal to 3x. We've just not been thinking of it like that up to now. So let's reintroduce the idea of functions then. So you probably remember at some point, maybe primary school or early on in secondary, you will have come across these things called function machines. Now they're usually a little introduction to algebraic equations. So what happens in a function machine, you start off with something called the input, and then it goes through the machine. When it goes through the machine, we've got certain things happening to it, certain processes, or we can call this part the function, and then at the end you get your output. So here if we put x into our machine, it then rolls through the functions, so it gets multiplied by 2, and then gets 1 added to it. The output comes out as 2x plus 1. So we can think of the output as the function that we carry out on the input. So say if I was to put 1 in as the input, my output would be 2 times 1 plus 1. So in function notation we can write this as f of x is equal to 2x plus 1. Let's look at that in a little bit more detail. Okay then, so what did I just mean when I said f of x was equal to 2x plus 1? So let's break it down. There's 3 main parts to function notation. The first part, the letter. So here we've got an f. This is simply the name of the function. We can use any letter that we want. You can even use any word that you want. You could call your function Batman if you wanted to. You could have Batman as a function of x is equal to whatever. F is the most common one, f for function. Now if you're dealing with 2 functions, the second one will usually be called g, but it's not always the case. The second part, the letter inside the brackets after the name of the function, this tells us what we're inputting into the function. So again, it's usually x, but it can be any letter. So that on the left we read that as f as a function of x, or in short we can just read it as f of x. So that's how we read the left hand side. On the right hand side, this tells us how to calculate our output when we know what the input is. So this part on the right really is the function part. It tells us what we do to the number that we put into the function to get our output. So let's have a look at working through some examples then and hope we can make it make sense. So f of x is equal to x squared. Find f of 5. So whatever's in the bracket, we're substituting that in as x. So if f of x is equal to x squared, f of 5 then will equal 5 squared. Now 5 squared is 25. So here f of 5 is equal to 25. F of 10, x becomes 10, so we get 10 squared, and that's equal to 100. F of 0, x becomes 0, 0 squared is equal to 0. F of minus 2, just be careful if you have negative signs, the negative gets involved in the function. So x becomes minus 2, so we get minus 2 all squared, which remember is minus 2 times minus 2, and then minus times a minus gives us a positive. So f of minus 2 there is positive 4. Okay, example 2. F of x here is 5x minus 9. Find f of 8. So x becomes 8. So f of 8 will be 5 times 8 minus 9, which is 40, minus 9, which is 31. f of 2 will be 5 times 2, minus 9, which is 10, minus 9, which is 1. f of minus 1 will be 5 times minus 1, minus 9. Now 5 times minus 1 is equal to minus 5. Then we're subtracting 9. That will give us minus 14. And then f of minus 10 is 5 times minus 10 minus 9, which is minus 50, minus 9, which is minus 59. Okay, example 3, g of x here. So we're dealing with a g function, not an f function. So g of x is equal to x cubed. So let's find g of minus 1. So minus 1 cubed is minus 1 times minus 1 times minus 1, which will be minus 1. So g of minus 1 here is minus 1. G of 5, that's 5 cubed, so 5 times 5 times 5, which is 125. G of minus 10 cubed, minus 10 times minus 10 times minus 10. That will give us minus 1000. And then g of 0, well 0 cubed is just 0. Job's a good one. Okay, so for the final example in this video, we're looking at an example with two functions. So the first question, we want to find f of 2 add g of 4. So let's work them out separately. So f of 2, well that's going to equal 5 times 2, which is 10, add 2, which will give us 12. And then g of 4, well, g of x is minus 2x, so minus 2 times 4 will give us minus 8. So f of 2 add g of 4 is 12 minus 8, which will give us 4. Example 2, f of 8 minus g of 5. So f of 8 will be 5 times 8 plus 2. 5 times 8 is 40, plus 2 will give us 42. G of 5, well minus 2 times 5 will be minus 10. So g of 5 is minus 10. So then the f of 8 minus g of 5 will be 42 minus 10, so that's going to whip around and become 42 plus 10, which will give us 52. So f of 8 minus g of 5 is 52. And then finally g of 7 add g of 2. So let's work it out separately. G of 7 is minus 2 times 7, so that's going to be minus 14. And g of 2, well minus 2 times 2 is minus 4. So our answer here will be minus 14 minus 4, which will give us minus 18. So g of 7 add g of 2 is minus 18. Okay guys, I hope that's been helpful. Be sure to check out the rest of the playlist where we're going to be looking at composite functions, which are things like fg of x and gg of x. And also we'll be looking at how to find inverse functions, and I'll go through a load of exam type questions too. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers guys.